Okay, so let's discuss about the heap area now. So based on our previous impressions about the heap area, it stores the class object of the loaded class file. That is, here in our example, the student.class files class object is stored inside the heap area. So what we can conclude from this statement is heap area is associated with storing of objects. That is object of class student class. Okay, class student class, not student class. Okay, so just as a word of caution before starting off with the key points, the heap area is in no way related to the heap data structure that we know. Okay, fine. So similar to the method area, JVM has also one heap area. For every JVM, one heap area will be created. Okay, so this heap area is again created at the time of JVM startup. This heap area will be created at the time of JVM startup, and one heap area will be created per JVM. This is the main key point about heap area. Okay, as we discussed just about from the diagram, that heap area is associated with storing of objects. So this point says that objects and the corresponding instance variables of a class will be stored in the heap area. Say for instance, the student class. The object of the student class will also be stored in the heap memory area. Object of the student class will also be stored in the heap memory area. That is different what we discussed just few minutes back. It's the student class object. Class object of class student. Okay, that is different. And this object which I'm telling about is the student class, students object, student classes object. So the student classes object is also stored in the heap area, and the class object of the student class is also stored in the heap area. Objects and also the corresponding instance variables. That is the instance variable. There might be some instance variables of the student class, say for instance marks, name, roll number, etc. These informations are present inside the object. So the values of these instance variables are also stored inside the heap area. Since this heap area is maintaining the values of the object, so it should also maintain the values of the instance variables. Okay, so this is about the storage. Now, okay, arrays are also stored in the heap area. Arrays are also considered as objects. Hence, arrays are also stored in the heap area. Heap area, like the method area, can be accessed by multiple threads at a time. And hence, the data which is stored in the heap area, that is the objects, the values of the objects, they are not thread safe. Okay. And also similar to the method area, heap area is also not contiguous or might not be contiguous. It may be allocated in a contiguous fashion or it might not be allocated in a contiguous fashion inside the memory area of the JVM. Right. So this is all about the heap area. Okay. So we'll be looking into a program to display the heap area statistics. Before looking into this program, we'll discuss some basic points. Say, for instance, we have a program p1.java, where p1 is the name of the class. And using this program, I want to display or I want to fetch the JVM memory statistics or the heap memory statistics of JVM, current heap memory statistics of JVM. So to let this happen, we have a object or we have a class known as runtime. This runtime class provides us with three methods. One is the max memory, then we have the total memory, and we have the free memory. The max memory returns the maximum amount of memory that can be allocated or that is currently allocated solely for the heap memory. So this is about the max memory. The total memory is whereas the total amount, like the amount of the max memory, which is currently being used by the heap memory. Okay. And the free memory is basically the amount of memory or the amount of total memory, which is currently unused by the heap. Fine. It's clear, I guess. Okay. So let's move on to our agenda slide. So here we have runtime objects, and basically this runtime class is object. This runtime is a singleton class. That is, only one instance of this runtime class or one object of this runtime class can be created at once. A Java program communicates with the JVM using this runtime object. And this runtime class is actually present in java.lang package. So this is how we get the object for runtime, runtime.getRuntime. Once we get this runtime object, we can call the following methods, which we just discussed in the previous slide. This max memory is basically the total amount of memory that has been allocated for the heap, solely for the heap. And this total memory is basically the amount of the max memory that is being currently used by the heap or currently allocated for usage or further usages to the heap. And free memory is basically the amount of total memory that is currently unused or unutilized. Okay, so using this knowledge, let's look into a program. So here I have a class named heap demo. We have this main method, that is everything will be running in the main thread. I have instantiated the object of runtime class. Since runtime is a singleton class, so we get its object in this way. And only one instance of this runtime class will be available throughout. And I have displayed this R using this runtime object R. I have displayed the max memory, max JVM memory that has been allocated solely for the heap. Then I have displayed the total memory. Then I have displayed the free memory. And lastly, I have displayed the consumed memory by subtracting free memory from the total memory. Okay, so let's run this program. Java heap demo. So this is the amount of megabytes which is currently allocated for the heap. This is the amount of megabytes which is currently being used by the heap, or for further usages this has been kept. Okay, and from this current initial memory, we have this amount of memory free. That is, a lot of amount of memory is free. That is, out of 238 we have 236 as free memory, and consumed is 1 megabyte, around 1. Okay, so this is our basic simple program. I have actually this max memory, total memory, free memory returns in bytes. So I need to divide it by 1024 into 1024 to convert it into megabytes. Okay. Okay, so let's see what is our next topic to be touched upon is how to set the maximum and minimum heap sizes. Okay. So we have a parameter known as xmx minus xmx. Say, for instance, I want to set it as 512 MB. So this parameter basically sets the maximum heap memory before running this Java. So I will be running this program using this xmx parameter. What this will do, it will set the maximum memory for this maximum heap memory for this program, heap demo. So let's see what happens. Okay, so the max memory was initially 3508. Now it is changed to 455. Nearly it is around, it is near to 512, almost near to 500. So from 455, we have 238 MB as the memory which is currently being used. Okay, for or memory which is allocated for use, for now current use and for future purposes. And this is the free amount of memory, and this is the consumed memory. Now I want to set this initial memory also using parameter. So for that, we have minus XMS. Let's set this initial memory to 256 M. Okay. So basically, initially we had 238. Now it has been increased to 245, near to 256. So in this way, we can change, or we can dynamically, like based on a programming requirement, we can set the maximum memory and the initial heap memory. So for setting the maximum memory, we have minus XMX parameter, and for setting the initial memory, we have minus XMS parameter. This is basically what the heap will solely use, 512 MB. And this is what the heap will currently be using for current purpose and for future purposes. Okay, so this is about the heap program done.